Thank you so much for watching this online video tutorial. Please like, comment and share the video, and please don't forget to subscribe to our YouTube channel at Good Better Best Online Videos for more content. Good day and thank you for joining us. So in today's video lesson we'll be looking at trigonometry revision. So let's get straight in. The first question says draw the following graphs in the given domain. Okay, so we're just going to start highlighting those important parts. It says in the given domain. Okay, show the coordinates of the turning point. Okay, so we're going to highlight our turning points and intercepts on the y-axis. Okay, for tan graphs though, show the image of 45 degrees and fill in the equations of the asymptotes. Okay, so let's have a look at our first question here. It says y equals 2 sine x, and then the domain they give us here is x is an element of minus 180 degrees to positive 180 degrees. So you can see I've already gone ahead and drawn the Cartesian plane. What this domain limit basically means that when we get to 180 degrees we cannot do any graph on the left hand side of 180, and we cannot do any graph on the right hand side of 180 degrees. So we are confined to the space in between the two 180 degrees. Okay, so let's go ahead and get stuck into this example. So it says here first, obviously y is equal to 2 sine x. So what we know is that well, I like to start my sine graph is right here in the middle. Okay, and because we can see that there's no shift in the graph, there's no plus or minus 1, we know we will still start here in the middle at this origin. And then what I'm going to do is identify what my turning points are. And so to know where my turning point is exactly, I need to look at my amplitude. And my amplitude says that we have an amplitude of 2. So which means this graph will go up to 2 and down to minus 2. You can see that's why I have this graph going up to 2 over here and down to minus 2 over here. So we know the sine graph is going to go up, and the turning point is at 90 degrees. Okay, so the turning point is at 90 degrees and we're going to 2 amplitude. This is how high the graph is going. And for this side of here we're going low down here to minus 2 and 90, right? And once I've done that, let me just write in the coordinates. So it's 90 and 2. This is minus 90 degrees and 2. Cool, don't forget the degrees, guys. So what we're going to do then is we're going to start drawing the graph here. We do the top half first. We start turning before we get there, and we come down, and we know that it's going to come down to 180 over here. Then from this point of view we can come down, start turning, and we're going to go to minus 180 over there. Sorry, it's a bit skew, guys, just bear with me. So we can see then that we have a graph that the only thing that's changed is the amplitude is 2. So everything in the sine graph basically stays the same except this amplitude change over here. And so we've indicated our turning points over there in the given domain and intercepts on the y-axis. This is the origin. Since this is the origin, we don't necessarily have to indicate that this is 0 degrees and 0, because they know the origin is exactly that. This mainly accounts for if there is a shift in a positive or negative direction, then we need to indicate, okay, that this is 0 degrees and 1, or this is 0 degrees and minus 1. Cool. Then moving on, we have here for B, it says y is equal to minus tan x, and the domain is x the element of minus 90 to positive 90. So you can see here once again I've drawn the graph or the Cartesian plane here. We know that we have 2 asymptotes here in this range or this domain given to us at minus 90 and positive 90. That's the same for a normal tan graph, right? And so we can just say sorry, not domain, we're going to say asymptote. Okay, we can just make that short in there. It's 90 degrees, and this side we can say asymptote is equal to minus 90 degrees. Okay, that's basically saying the equation for the asymptotes. Cool, so that's the 2 equations. Then obviously we know that because there's no shift, we know that our tan graph is going to start here in the origin, right? Because remember, it's going to shoot off in both directions, and we only have to end up drawing one tan graph since we're doing minus 90 to 90, right? So looking at this, we can see though that there is a minus in front of the tan, which means that this graph is opposite, and which means it's being basically reflected about the y-axis. Okay, So we know also that the tan graph, it has a turn, so it's going to come out and it has a turn at 45 degrees, right? 45 degrees and 1, provided that nothing has changed. There's no change in this amplitude over here, right? So the amplitude basically changes where this graph is turning at 45 degrees. So it will stay turning at 45 degrees and 1. So I'll say here, this is 45 degrees and 1. Don't forget the degrees. So the graph's going to come down, it's going to start turning here and head downwards, cool? And then we can just go ahead and draw the other side. We only need to paint the image for 145 degree angle. Let me just neaten that up a bit. Here we go. And just like that, we've given them everything they want for this graph. The equation for the asymptotes and then that picture of 45 degrees. Moving on now, we're going to look at y is equal to cos x minus 1. So what is the change here? We have a normal cos graph except for the fact that we are shifting 1 unit down. Cool. So just give me a second quickly. There we go. I just had to neaten that up for you guys. So we know that the cos graph, it usually has a turning point on the y-axis, right? The turning point is on the y-axis, so we're going to start on the y-axis basically in this case. But because we shifted 1 down, so it would have had a turning point here at y is equal to positive 1, right? So that would have been the turning point. But because we are shifted 1 down, that means the turning point will be now at, you guessed it, it's going to be at the origin. Cool. So what ends up happening is, remember the turning point now for our cos graph. So initially the graph would have gone down and crossed over here at 90 and 0, right? But now it's going to basically replace that point at 90 and minus 1. Oops, sorry. 90 and minus 1. And the turning point would have been at 180 and minus 1. But now it's going to be at 180 and minus 2. Which is going to be somewhere down here. And so remember, the domain says that we can't go past this point, so we'll just indicate here this is 180 degrees and this is going to be minus 2. Cool, so we only have to indicate the turning point, remember? And then obviously the other point over here is going to be somewhere down here. I didn't fit the minus 2 on here, unfortunately, guys. It's going to be minus 180 degrees and minus 2. And so this will go down as well, like that. Cool. And so that's the y is equal to cos x minus 1 graph in this case. So now we're going to move on, guys. It says here by the next question, determine the equation of the following sketches. Cool. So if we're looking at these sketches, guys, let's try and figure out what we're looking at first. So we can see that we are dealing with a cos graph. Why do we know that? Because the turning point is on the y-axis. So we can just start here by saying y is equal to cos x. We'll leave space on both sides in case there's a shift or amplitude change. So let's look. Is there any shift? If there has been a shift, that means that these y values will be different. The two y value turning points will be different. We can see that the turning point values are the same, except obviously one's minus and one's positive. Because they're both 2, we know that there's no shift in the graph. And so all we need to then identify is what is the amplitude of the graph. And obviously we know the amplitude is usually 1, so that's why there'd just be a normal cos x. But because the amplitude is 2 now, because remember the graph goes from 0 up till 2, we put a 2 in front. Okay? And so the equation for this graph is y is equal to 2 cos x. Moving on here to b, we have a tan graph, as we can see clearly. So y is equal to tan x. So what we need to do now is identify, is there any change in the amplitude? Remember the amplitude in this determines where that 45 degree turn is, right? And then is there any shift? Because we can see that the tan graph is still going through the origin here, there is clearly no shift. So all we need to know is what is the amplitude change, and we can see that the amplitude change here is 2, right? It's gone up by 1 because now remember the 45 degree turn used to be at 1, but it's changed to 2 now. So the amplitude change was 2. So we can say 2 tan x. Then we move on here to C. What type of graph are we looking at? Well, we can see that the graph goes through the y-axis, but it doesn't have a turning point on the y-axis. that would tell us then that this is a sine graph. So we can say y is equal to sine x. Now we need to look at, is there amplitude change? Okay, we can clearly see that the graph has been shifted, but is there amplitude change? And the way we can tell that is by looking at the distance between the point that crosses over the y-axis and the turning point. Okay, and the reason that is because, remember, we usually look at amplitude as being from the origin to the point at which the graph goes up till, right? Or the turning point. But because obviously now we're not on the origin anymore, this still counts as the point that's in the middle of the graph. So we need to look at this point over here. We can see that from minus 0.5, which is this point, to positive 0.5, that is a difference of 1. Okay? And because it's a difference of 1, we know the amplitude then is 1, which means there's been no amplitude change. So there's not going to be anything in front of sine x. What we need to figure out now is what is the shift. And that's easy to tell because we remember this used to be at the origin, this point, right? It used to be the origin. So which means this used to be 0. So what is the difference? The difference is minus a half. So we can say minus 0.5, or you can say minus a half, like that. Either one will do. And that's going to do it for that question, guys. Okay, guys. Moving on to the next part. We're obviously done with trig functions now. Hopefully you guys are okay with were okay following along, and you guys sort of made sense of most of that stuff. What we're moving on now to is our normal trigs, basically. So you guys are just going to do question 3 here for me, please. So it says in triangle ABC, angle B is equal to 90 degrees. So write in terms of A, B, and C. Cool. Let's give it a shot, please, guys. Moving on now, guys. It says here in question 3, in a triangle ABC, angle B over here equals 90 degrees. So they say write in terms of A, B, and C. Which is pretty simple, okay? So we're looking at sine A first. What that means is we're using this angle over here as our angle. Cool. So everything else will be in reference to this angle here by this side A. So we know we're doing sine. So sine is equal to, obviously the equation for that ratio is opposite over hypotenuse. And so we look here, looking at this angle over here, which is the angle A. Cool. The opposite side is A, so that will go on top. And the hypotenuse we obviously know is B, because that's opposite the right angle. Then we move on to cos C. So we're dealing with this angle over here. Okay, so they're just indicating which angle we're dealing with, so that's over here. Cos is adjacent over hypotenuse. Don't forget to write in your equation for your ratio, guys. And then the adjacent side to this angle is going to be A, and the hypotenuse, still the same, is B. Then we move on to tan A. We know tan is opposite over adjacent, and the angle we're dealing with, they tell us, is A. So we're going to be dealing here again. The opposite side is A, and the adjacent side is C over here. And then moving on to cosec A, we know that cosec A is the inverse of sine, so we can say the inverse of sine A. And because we've already worked out sine A, we don't need to indicate what sine A is equal to. And so all we need to do then is just flip this around, because remember, so cosec A is the inverse of sine A, and the inverse of sine A is the inverse of this fraction over here. So A over B now becomes B over A as our final answer there. Okay, guys, let's go ahead and look at question 4. So it says solve for B, 1 decimal place. So we need to solve for B and round off to 1 decimal place, whatever our answer is. So when we are solving for B, all we need to do is basically get B by itself. And in this first case, we have cos B is equal to 0,18, which is a pretty simple sum. Because all we need to do to get beta by itself is shift cos across, right? So we have beta then. We then have beta over here is equal to cos to the negative 1, open bracket 0,18. Cool. Then what you're going to do is you're going to put this in your calculator as is. You press shift cos. That's why we call it shift cos, guys. Press shift and you press cos. Put that in in the bracket over there, and your final answer will come out to 79.6 degrees once rounded off. Okay, so once rounded off, you should get 79.6 degrees. Then we're looking at 2 tan beta over 5 minus 1 is equal to 0. So all we need to do then is first get the fraction by itself, so we take that 1 over, so we have 2 tan beta over 5 is equal to 1. Then we need to get the 2 tan beta by itself, so we have to basically get rid of the fraction, so we times by 5 on both sides, so we get 2 tan beta is equal to 5, and then to get the tan beta by itself we have to divide by 2 both sides, so we get tan beta is equal to 5 over 2, and then beta by itself we have to do beta, shifting tan across, so we get tan to the negative 1, 5 over 2, and once we put that in our calculator we get that beta is equal to 68.2 degrees rounded off to 1 decimal place. Next up, we're looking at question 5. It says solve the following right angle triangles giving all unknown sides and angles correct to 1 decimal place. So this is going to be our classic example of using what you have to find what you want to find. And straight away what I'm going to look at finding is one of these two fractions over here. Let me just fix this quickly. Okay, cool. I'm looking to find one of these two fractions over here, okay? So either angle A or angle C. So I'm going to look at finding angle A first. So what I'm going to do is I'm going to say I'm given in the case of angle A here, what I'm given is the opposite and the hypotenuse. So I'm going to say opposite, which is obviously 2.4, and the hypotenuse, which is 3.7, okay? So I'm looking to find angle A. So I'm going to say find angle A, right? Which we don't know yet. So obviously, seeing that it's opposite and hypotenuse, we know we're dealing with the sine ratio. So we're going to say sine A is equal to opposite over hypotenuse. So sine A is going to be equal to 2.4 over 3.7. And then obviously to get A by itself, we have to shift sine across. Sine to negative 1. 2.4 over 3.7, and so in your calculator you're going to go shift sine 2.4 over 3.7, and you end up getting your final answer of 40.4 degrees. Remember, that's rounded off to 1 decimal place. Then next up what we can look at finding is obviously this other fraction over here, or this other angle over here, sorry. So this angle C. So if we're trying to find angle C, remember you always indicate that angle like that. Let me just also put that there. So angle C is going to be equal to 180 degrees minus, obviously the 40.4 degrees that we just did, minus 90 degrees. Okay, cool. And what you can go ahead and do is write in your reason, okay? So your reason is going to obviously be angles of a triangle equal to 180 degrees. I'm just not going to write it for the sake of space. And so what you end up getting as your final answer is that angle C is going to be equal to 49.6 degrees. And then lastly, we need to find the length of the side C over here. And so we're going to write once again, we are given. So technically we aren't given this, we found this, but it's just a way to follow the method, okay? So let's say we're going to use angle A to find it. So we are given the opposite side, which is obviously going to be our 2.4. What we need to find is our adjacent side, okay? So here next to given, we can also write in, we given angle A, which we found to be 40.4 degrees. And then we need to find the adjacent side. Okay, cool, which is obviously equal to C, which is what we need to find. And so we can see we're using opposite and adjacent, so we're using the tan ratio. So this is going to be tan A is equal to opposite over adjacent. And so we're going to substitute in everything we have. So we have tan 40.4 degrees is equal to the opposite, which is 2.4 over the adjacent, which is C. Cool? And so now all we need to do now is obviously times C out of here. So we times C. If we times by C both sides, we get C tan 40.4 degrees is equal to 2.4. And obviously to get C by itself, we divide by tan 40.4. So C is going to be equal to 2.4 over tan 40.4. Cool. So what you're going to do is you're going to put that in your calculator as is. You're going to say 2.4 over tan 40.4, and you get your final answer of 2,8 once you round off to your nearest single decimal place. And just like that, we found all of the sides and angles in the specific triangle. Moving on now, we are going to look at this last example now, which is B. The exact same instructions, just got to find all the unknown sides and angles. Obviously to find angle Q, it's going to be quite easy. We're just going to go and work that out quickly. So to find angle Q, we're going to once again use the sum of the angles in the triangle. So we already have this 30-degree angle here, then we have this 90-degree angle here. So we can say angle Q is equal to 180 degrees minus 30 degrees minus 90 degrees, sum of angles in the triangle, da, 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 da. And then you get Q, angle Q is equal to, so obviously 30 plus 90, that's going to give me 120, minus that from 180, we get 60 degrees. Cool. We can just fill that in there, 60 degrees. Okay, so what we need to do then is find the size of the side Q and the side P. So let's go ahead and find the size of side Q first. So we're going to find size Q. So we're going to say given. So we are given the angle of, let's use the angle of P over here, which is equal to 30 degrees. Okay. So P is equal to 30 degrees. Then we're also given the hypotenuse over here. So the hypotenuse, which is equal to 20. What we need to find is our side Q, right? Which is also our adjacent side. Okay, so it's our adjacent side. So we know we're dealing with adjacent and hypotenuse, which is going to be cos, right? So we can say cos theta or cos x, or whatever you want to say. Cos theta is equal to adjacent over hypotenuse. We're going to substitute in all of our values that we have. So cos 30 is equal to the adjacent, which we don't have, over the hypotenuse, which is 20. And so obviously to get a by itself, we have to times out this fraction, and so we times 20 both sides. So we get a is equal to 20 cos 30 degrees, and you'll put that in your calculator just as is, and you'll get a final answer of 17.3. Remember, round off to one decimal place. And then lastly, or before we actually finish that off, what we're going to say is, obviously they asked us to find Q, so we have to say, indicate that therefore Q is equal to 17.3, because Q was this adjacent side. Now we need to find P, which is this opposite side, okay? So we need to find P. So we can say once again, given, we can use the same angle once again, given angle P, which is equal to 30 degrees, and then also given, we'll use the hypotenuse once again. We'll say given the hypotenuse, which is equal to R, which equals 20 degrees, sorry, not degrees, just 20 units in length, and then we need to find P, right, or the opposite side. So equal to P is what we need to find. Cool. So what we're dealing with here is opposite and hypotenuse, which is the sine ratio. So we can say sine theta is equal to opposite over hypotenuse. So we say sine, substitute in the 30 degrees, is equal to opposite, which is P, over hypotenuse, which is 20. Cool. And once again, to get P by itself, we times by 20 both sides. So we get P is equal to 20 sine 30. And so once you put that in your calculator, you should get a final answer of 10. So P is equal to 10. And just like that, guys, we've finished our revision once again. Thank you so much for joining us, and I'll see you in the next lesson.